Hello, Algebra 1 students. This is your notes on quadratic functions, and it's your 9.2 notes, and you're going to have some things in here that you're going to need to memorize. So be aware of that. Here we go. We're going to talk about quadratic functions, and the big idea is that in a quadratic function, y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. And I want all of you to say that vocabulary with me, the axis of symmetry. Say that out loud. All right, the axis of symmetry is located at this line. It's an imaginary line. It represents the very middle of your parabola, and it is the exact same on both sides. It reflects each other on both sides. So it is at x equals negative b over 2a. Later in this unit, you're going to learn the quadratic formula, and this is half of the quadratic formula. Okay, so you'll need to know the axis of symmetry. You'll also need to know the vertex. So I want you to say vertex out loud with me. Vertex, go, vertex. Okay, so the vertex of a parabola is the very tip of that parabola. So you need to know where that is. It's negative b over 2a, which is your x-coordinate of your axis of symmetry, and then your y-coordinate of your axis of symmetry. Well, if you plug that in, what this means is f of x. So if you plug in that x-coordinate into your function, you'll get your y value for your vertex, okay, or your y-coordinate for your vertex. All right, here we go. Let's show you how to do this. All right. Come on, zoom in, computer. And I'm going to take my keyboard off of here. So we should have, we're looking for the axis of symmetry, and I need to turn the pen on. Common problem that I have. We're looking for the axis of symmetry and the vertex for this quadratic function. So in this quadratic function, a is equal to 3, b is equal to a negative 6, excuse me, and c is equal to 5. So the axis of symmetry is located, x is at negative b over 2a, which is 3. So a lot of kids, when they see this negative for 6, or their b is already negative, they forget to actually put their negative out front right here as well. So a negative times a negative is a positive, so I've got 6 over 2 times 3, which is 6, which is equal to 1. All right, so my vertex of my parabola is where this value, this x value of equals 1, is actually substituted into my function. All right, so the function as x is equal to 1 is equal to 3 multiplied by 1 squared minus 6 times 1 plus 5. Okay, and then you have to do your order of operations. So 1 squared is 1, 1 times 3 is 3. Negative 6 times 1 is negative 6. And then plus 5 is still there. So we've got 3 minus 6, which would be equal to negative 3, plus 5, which would be equal to 2. All right, so my vertex is going to have coordinates x comma y like this. And so the x value is my number 1. My y value is my 2. So my axis of symmetry is at x equals 1, and my vertex is at the point 1, comma 2. Okay, so for number 2, we threw in one that was going to have a little bit of a question mark on what b is going to end up. Okay, so we've got a is equal to 4. We've got b equal to 0 in this case, and c is equal to negative 7. All right, so when I'm doing my axis of symmetry, I plug that into my formula. X is equal to negative b over 2a. Okay, Doesn't matter what anything else is. If I've got 0 in my numerator, my axis of symmetry is going to be at 0. All right? Or my axis of symmetry in this case is the y-axis. We'll talk about that a little bit more when we're graphing. Okay, so my vertex of my parabola is going to be where x equals 0, so the function is x is equal to 0, or I can substitute 0 everywhere I see an x. Okay? So 0 times 0 is 0. 0 times 4 is 0. 0 minus 7 is negative 7. So y is equal to negative 7. Do not leave your answers like this. I will take points away. You need to give me the answer to your vertex as a coordinate or an ordered pair. It needs to be 0, negative 7. I have a lot of Algebra 1 students try to just stop and square off that and say, hey, that's my answer. That's not your answer. Your answer is a point. Your vertex is the point on your parabola where it reaches the very tip of that parabola and starts going the other direction, whether it's a maximum or a minimum, okay? So, got to show me that. All right, number 3. For number 3, I've got A is equal to 1/2. B is equal to positive 6, and C is equal to negative 3. My axis of symmetry is located at negative x is equal to negative b over 2a. All right? So negative 6 over 2 multiplied by 1/2, or 2 divided by 2 is just 1. And so my axis of symmetry is at negative 6. My vertex is going to be where I plug that into my function for x. So the function is x is equal to negative 6 is equal to, or I'm going to substitute every single time I see an x, I'm going to plug in negative 6. So I have plugged that in, or I have substituted that into my equation. Okay? Well, negative times negative is positive. 6 times 6 is 36. 36 times 1/2 would be 18. Okay? 6 times 6 is 36, so 18 minus 36 minus 3. All right, 18 minus 36 would be a negative 18. Negative 18 minus 3 is a negative 21. Don't just stop here. Y is equal to negative 21 in my vertex. Don't just stop here. Again, you need to leave that as an ordered pair. You need to give me your answer as a coordinate. So it's negative 6, negative 21. That is the location of the vertex of this parabola. All right, so on number 4, A would be equal to negative 2, B would be equal to 8, and C would be equal to 9. Okay, so I'm going to find my axis of symmetry. Axis of symmetry is located at x is equal to negative b, so negative 8 over 2a, which is negative 2, or a negative 8 over a negative 4, which is actually a negative divided by a negative, so it's positive. 8 divided by 4 is 2. Okay, so my axis of symmetry for this parabola is at 2. So what I'm going to do is put a dashed line at x is equal to 2. And my line needs to have an arrow on both ends. In this unit, if you do not graph and label the axis of symmetry, okay, then if you have not done this dashed line, you have not graphed your axis of symmetry, I will take points away. So you need to be aware of that. All right, so your vertex is where I plug in or I substitute x value for the axis of symmetry into the vertex. In other words, my vertex is certainly going to be somewhere along this dashed line. That is my axis of symmetry, and this is how we find it. Okay, so I've got the function as x is equal to 2, which means I'm going to substitute everywhere I see an x. I'm going to substitute my axis of symmetry value, or my x value. 8 times 2 plus 9. So 2 times 2 is 4. 4 times negative 2 is negative 8. 8 times 2 is 16. and that positive 9 is still there. This is going to end up being positive 8 plus 9, or 17. Okay, so let's actually scale our graph just a little differently. So let's go by 2s. So this would be 2, 4, 6, 8, 10. And then 20 should be up there. 12, 14, 18. I just skipped 16, 16, 18, 20. Okay, so this is, in fact, 20. So 17 would be, let's see, 12, 14, 16, 17 would be right there. So my vertex of my parabola would be right there. Now, for this unit, what I want you to do is actually pause your video, and I want you to take a look at the graph on your graphing calculator, whether that be Desmos or whether that be your graphing calculators, your TIs. Okay, hopefully you actually paused your video and plugged your or entered your function into your graphing calculator. One of the reasons why I like Desmos is because of how intuitive it is. And you can see as I'm using Desmos here, all I have to do is touch the vertex of the parabola and I can actually see the coordinates, which is a very simple fact check. You guys are allowed to use Desmos in my class, and so you can fact check simply by entering your function into Desmos and make sure that you have calculated your axis of symmetry and your vertex correctly by looking at that. And when we are graphing in this unit, it's not going to be like our linear equations unit where I made you actually come up with the entire t-table, 4-column t-table, and kind of like what we did in the first videos. For this unit, I just need your critical points. Your critical points would be your y-intercept, which oddly enough is still the constant y value in our function. And then I need you to have those 2 points where your x-intercepts are as well. Later in this unit, we're going to come up with how to actually calculate those by hand instead of having to use the graphing calculator to find those crazy old decimals. I just need you to know where those critical points are, and if you sketch those critical points pretty well, then we're cool. So my vertex is there, my y-intercept is at positive 9, my graph of my parabola opens up downward, and then it's at almost negative 1 and almost 5. So almost negative 1 and almost 5. 1, 2, 3, 4, 5. So almost there and almost there. Okay, and remember, it does not come to a point. It actually has a curve. Okay, and even up here at my vertex, it comes to a curve. And should look something like that. Perfect parabola Mr. Bear has sketched there. No crooked lines at all. All right, guys, YouTube does limit me on 15 minutes for my YouTube videos, so I need to speed up just a little bit. What I want you to do is pause your video. I think you're capable of coming up with your axis of symmetry and your vertex by hand here, so I want you to pause your video and show me that you can do this. All right, Algebra 1 students, I actually realized while I had my video paused there that I did not give you your vertex in an ordered pair in number 4, so I missed points there. So I went ahead and did that for you, but I came up with my axis of symmetry and my vertex on number 5. This is what you should have come up with, is x equals 1, so I expect a dashed line at x equals 1, and I'm using a different color here so that you can see the different graphs even though they're on the same graph. So x is equal to 1 is my axis of symmetry. 1, 1 is where my vertex is going, so it goes right there. And I went ahead and plugged that into Desmos. I can see that my critical points I have 2, 4, 6, so 5 would be right there. A y-intercept at 5, and I don't have any other critical points on this parabola, so I can go ahead and sketch my curve of my parabola like so for number 5. And again, folks, I am limited on YouTube, so I have to give you another pause right here. I'm going to pause the video. I'm going to do this entire problem and graph it, and so that way you've got the answer before we have to leave. All right, folks, here is your answer for number 6. We will see you in class.